So we got our bike analogy, one frame, two wheels, one bike. Love it. Okay, let's do this. Let's say we have, I don't know, 7 frames. Let's say we have, I don't know, 18 wheels. First question, I want to know how many bikes can we make? So that's a limiting reactant problem. We're going to take that guy over. We're going to take that guy over. So here we go. So there we go. My theoretical yield is 7 bikes, right? 7 bikes is what I should be able to make. Obviously, the frames are the limiting reactant. The wheels are in excess. That should be nothing new. We covered all of that. Like that should be, we should be golden there, right? Here's the extension I'm going to add to it. Okay, great. Frames are the limiting reactant. Wheels are in excess. Here's my question. I want to know how much of the excess reactant will remain unreacted. Like how much of the excess reactant am I going to have left over? Okay, now there are 2 ways to do this. And I'm going to show both ways with the bikes, and then we're going to do it with the chemistry, and we'll show both ways with the chemistry. So option 1, this is how I personally do it, but I do want to show the second way. Here's what I do. To figure out how much of the excess reactant, in this case wheels, is left over, what I do is I take the amount of product that the excess reactant would have let you make, and I subtract the amount of product that the limiting reactant lets you make. So what I do is I do 9 bikes minus 7 bikes, and that tells me I could have made 2 extra bikes. If the limiting reactant had not run out, I could have made 2 additional bikes, or I could have made this much extra product from that excess reactant, but it wasn't allowed because the limiting reactant cut me off. Now what you can do is you can take that extra amount of product, the 2 extra bikes, and now we can rip those back apart. We're going to take the amount of extra product back to the excess reactant, and that will tell us how much of the excess reactant remains. I call this the subtraction upfront method, patent pending, because we're doing the subtraction up front. The next method is going to have subtraction on the back end. Okay, so let me recap. We're not done. I took the amount of product the excess reactant would have let me make, and I subtracted the amount of product the limiting reactant lets me make to get how much extra product the excess reactant would have let me make. Now I'm taking that extra product, ripping it back apart, and saying how much of the excess reactant does that equate to. So we're going to take 2 extra bikes over 1, and we're going to do our ratio. 1 bike to 2 wheels, and that's 4 wheels left. 4 wheels left. I personally, when I do chemistry, I do it this way. Okay? There is another way, though, and I want to show it to you. Here's the other way. The other way is this. Once you know what the limiting reactant is and the excess reactant is, what you can then do is this. You can take the limiting reactant to the excess reactant. And that will tell you, if I convert the 7 frames to wheels, that will tell me how many wheels I'm going to consume. And then we subtract it on the back end. If I have 18 wheels and I figure out how many I'm going to use, if I subtract, that'll tell me how many's left over. So this is the subtraction on the back end method. you take the limiting reactant, so 7 frames, 1 frame to 2 wheels. That's going to require 14 wheels. That's how many wheels are going to get used up. 14 wheels will get used. And now I can take the amount of wheels I started with, 18 wheels, and subtract the amount of wheels that I'm consuming, 14 wheels. There are going to be 4 wheels left, ladies and gentlemen, 4 wheels left over. You got to pick the one that made the most sense to you. And you got to do that with the chemistry. Okay? Here's what we're going to do. I'm just going to make up another limiting reactant problem. I'm going to pop it up here on the board. Okay? We're going to start by, like, give me a theoretical yield, determine the limiting reactant, the excess reactant. We're going to check in at that stage because I don't want you to have a mistake and take this thing all the way to how much of the excess reactant is left over and you got a molar mass that's wrong somewhere, right? So we're going to do one more. We're going to do the whole shebang here, okay? And then we'll take a break, right? Probably a much earned break with all this stoichiometry flying around. Oh my goodness. You know, I've taught at 3 different high schools, you know, and it's amazing what each school, you know, you think, oh, you know, the Commonwealth of Pennsylvania's got standards and everybody should be doing about the same thing, and they just are not. Oh my goodness. You know, some high schools teach limiting reactants, some don't. When I was at Governor Mifflin, we did limiting reactants with like sandwiches, right? You know, like you got 8 pieces of bread and 6 pieces of cheese, and what's going to run out? It was, you know, and then township, we do all this and then some. So some of you may have seen limiting reactants in high school, and this could be a review. Some of you could be the first time you've ever seen it. It's not really your fault. It's like what high school you went to. I know it's crazy. Anyway, let's do. Oh man, let's do a single replacement reaction. Why not? Right? Do. First thing, go ahead and balance it. You need the practice. I don't. I would. Big tip number 2. This thing. So 2 nitrates, we're gonna pop a 2 there. 2 silvers, we're gonna pop a 2 there. Cool. Hopefully, I'll balance that, right? Okay, let's do a limiting reactant problem. Let's do this. Let's say we allow. Oh man, I don't know. Let's say we allow 10 grams of zinc to react with 10 grams of silver nitrate. I want to know, let's take it to the silver. I want to know the theoretical yield of silver. So I want to know a couple things. I want to know, hey, if I allow 10 grams of zinc to react with 10 grams of silver nitrate, how many grams of silver can I make? I want my theoretical yield. Then I want you to label the limiting reactant, which one of these is the limiting reactant. I want you to label the excess reactant. Then I want you to stop. Don't try to do the next step. Okay, because if you got something wrong, oh, this would be painful, right? That would just break my heart. You'd be erasing so much. So we're going to take this guy over. We're going to take that guy over. We're going to grams of silver, and we'll check in. What we find is that the 10 grams of zinc would let us make 33 grams of silver. And we find that the 10 grams of silver nitrate would allow us to make 6.35 grams of silver. So the 6.35 grams of silver, that is my theoretical yield. I'm going to label that as such. And now I can also label my limiting reactant and my excess reactant. So my limiting reactant is the thing that runs out first. That's the silver nitrate. So, and then my zinc is in excess. So hopefully we are all on the same page there. Okay, now you got to decide. So now I'm going to ask how much of the excess reactant remains. So how much excess reactant remains? How do we get this? You got to decide what kind of person you are. I'm going to show both methods. Okay. Here's the first option. Take the amount that the excess reactant would let you make, the amount of product the excess reactant would let you make, subtract the amount that the limiting reactant lets you make. Figure out how much extra product you could have made, then rip that product back apart and take it to the excess reactant. The other option is to take the limiting reactant to the excess reactant. 10 grams of this to question mark grams of this. Figure out how much of this is used up and then subtract. So I'm going to do this one first, then I'll show this one. So decide which person you are. Try it. I'm going to go over it here. I'm going to give you like 2 minutes. Okay. If you're totally stuck, just wait. I'll go over it. I'll show both methods. I encourage people usually to write both methods down because, maybe you're not sure which kind of method you prefer. So I'd like you to try how much of the excess reactant remains. Give it a shot. If you're totally stuck, just hang in there. All right. Let's take a look at this first method. This is how I personally do it. I personally take the 33.0 grams and subtract the 6.35 grams. Okay, and we figure out how much we can make. So 33 minus 6.35. That's 26.7 grams of extra silver. Now, why did I round to the 10th place? Addition, subtraction, sig fig rules. Tenths minus hundredths. I went to the tenths. These problems start getting that long, I might catch you a break on the sig figs, right? If you messed up. Okay. All right. So now what we need to do is take the 26.7 grams of extra silver back to the excess reactant. So here we go. It should be pretty fast because we have all the molar masses, right? So here we go. 26.7 grams of extra silver over 1. Divide by the molar mass of silver, 107.87. And then it's 2 moles of silver to 1 mole of zinc. And then 1 mole of zinc weighs 65.38 grams. So 26.7 divided by 107.87 divided by 2 times 65.38. And we get 8.09 grams of zinc remain. 8.09 grams of zinc would remain unreacted. So we put in 10 grams and 8.09 grams of zinc would still be sitting in there. Only 1.91 grams were able to actually react. So that's how I personally do it. Again, how did I do this way? We take the amount the excess reactant would have let you make minus the amount the limiting reactant lets you make, figure out how much extra products you could have made, rip that extra product back apart, and figure out how much reactant would be left. I do want to show the other way really quick. So first of all, do we have any questions on this way before I erase it? Because I'm out of space. But hopefully we'll remember that 8.09 gram. We should get the same answer here. Okay, so let me show you the other method. Should have left that there. Oh, well. The other method works like this. Now that we know that the silver nitrate is the limiting reactant, we can convert that to zinc. And what that'll allow us to do is if we convert the 10 grams of the limiting reactant to grams of zinc, that's going to tell us how much zinc we need to react with that. Essentially, it's going to tell us how much zinc is consumed. Okay, some people like doing it this way. So here we go, 10.0 grams of silver nitrate over 1. That's got a mass of 169.88 grams. And then that's a 2-to-1 mole ratio. 2 moles of silver nitrate to 1 mole of zinc. And then zinc has a mass of 65.38 grams. And that's 1.92 grams of zinc consumed. See how we figured out that 1.92 grams of zinc would be used up? Now that we're not done, because this is the subtraction on the back end method. Now what we need to do is take the amount of zinc we put in there minus what's used up, and that'll tell us what's left. And if we do that, we're going to get hopefully the same answer we got before with one less sig fig. And sometimes that's just how it works. So we got 8.1 grams of zinc left. 8.1 grams of zinc left. That's how much we remain. You got to figure out which method you like best. Okay, which one is your favorite? Do you like to subtract and then take it back? Or do you like to convert the limiting reactant to the excess reactant and then subtract? It's totally up to you. I'm hoping at least one of those methods made sense to you. If both of them made sense to you, that's even better, right? You could just pick whichever one you feel like doing that night. So, cool. I'm feeling good about that. That gets us through limiting reactants, so I'm feeling good. Let's see, what time is it? It is 7:17, and Gunnar Henderson just did a grand slam for the Orioles. That's what I'm talking about.